sit down, we want to take a look at a couple of equations. We're going to use these equations that model height after an object is launched or thrown. So I'm assuming possibly in physics you guys have seen some of these already. So the equation negative 16t squared minus v sub 0 t plus h sub 0 is used to model an object that is launched or thrown. V sub 0 stands for initial velocity, which is why it's being launched or thrown. Something's pushing it, giving it some force. Negative h equals negative 16t squared plus h sub 0 is just used to model the height of an object that's dropped. Meaning all I'm doing is letting go. I'm not pushing it down. I'm not putting any force behind it, so there's no initial velocity with that. So h stands for the height. So if they're asking me to find a specific height, that means you're going to be looking for h. T is the time, so if they're asking me to solve for the time, this is where basically you are solving for x. So this is where we would use this quadratic formula for, as if we're solving for t. And then initial vertical velocity, these will all be values that they give us. So these will be given to us. And what we'll need to is plug them into the formula to either find a specific height, so we want to know what is the height of the ball after 5 seconds, or to find at what time does it reach a specific height. All right, so let's take a look at what we're doing here. A free throw shot with an initial velocity of 21 feet per second. So as soon as I see initial velocity, I know I'm using that first formula. I've shot something. I know I'm using that first formula. From a height of 5 feet above the ground. The height at which it's launched from is that h sub 0, guys. That's what it means from initial height. The ball was initially 5 feet above the ground when it was shot. We want to know how much time until the ball hits the ground. So here's what we have. We have a person shooting a basketball, and we want to know when it hits the ground. What's the height when you hit the ground? 0. So when they ask when does something hit the ground, when does the ball hit the ground, when does a rock hit the ground, when does a rocket hit the ground, they want to know when does h equal 0. Okay? So even though they don't give you a specific height here, guys, as soon as they say the ball hits the ground, that's your h sub 0. Or I'm sorry, that's your h equaling 0. Okay? So let's start filling out that equation. Let's start filling out our equation. We've got h equals, we start with negative 16 t squared. And I know I'm going to leave t in there because that's what they're asking me to find. They're asking me to find time, so I don't have any number to plug in there. I then have, I'm going to need to cursor back, it says minus v sub 0, that initial velocity. What's our initial velocity for this basketball? 21. Yep, it says minus 21. And then you're still going to have t here. Don't leave out your variable. And then it says plus h sub 0. So h sub 0 is your initial height. What's the initial height of our basketball? 5 feet. So this initial height of 5 feet above the ground is plus 5. And so we want to know when does the height equal 0. So I'm going to plug 0 in for h.
This problem is killing me.
Why, Mr. Clone?
Because the basket's 10 feet high. How's it going to go in?
Because we're shooting it up with a parabola. We're putting an arc to it, which is why it's a quadratic
Only 5
formula.
feet above the ground.
But you shoot it from 5 feet.
No, that's what I'm trying to see. Am I not understanding this?
Yeah.
Is
So
leaving from 5 feet?
you are 5 feet. The ball's at 5 feet. Someone's holding it 5
At
feet
5
above the
feet.
ground.
Okay.
They're going to launch it towards the basketball.
Gotcha.
Or towards the basket. So they're going to throw it up. We're not throwing it in a
It's not-
straight line.
It's not going 5 feet high.
No, it's not going. It's launched.
Gotcha.
It's thrown. It's shot from a height 5 feet above the ground. So they're
Gotcha.
holding it 5 feet. So
All
must
right,
be a
good.
6 foot tall player maybe, or
Right.
to hold it at 5 feet. Well, no, because they're going to be up here when they shoot it, so it doesn't need to be that tall of a plane. So does that help out?
Now I'm good.
All right, so that's why it's a quadratic, because it goes up and then it comes down. Ladies and gentlemen, we're going to use our quadratic formula, and in order to use it, it has to be set equal to 0. So is our quadratic equation set equal to 0 right now? Yeah. Any questions at where I'm getting these 4 values from? Where did the 0 come from? Why did we have 0? Because it's hitting the ground. Where does negative 16t squared come from? The equation. Where did negative 21 come from? Initial velocity. And where does 5 come from? The original height. Good thing Eric's in here. All right. So, ladies and gentlemen, let's go and learn how to run our program. So, to run your program, what's wrong, Keisha? Initial velocity is the rate at which it's thrown. So it'll say initial velocity was 21. Look at your equation. Does the formula say minus v sub 0? It says plus. Did I have the wrong? Is there a typo in mine? Guys, do my notes have a typo? Is it plus v sub 0 or minus v sub 0? Then I have a typo on my notes. I'm sorry. Thank you, Keisha, for bringing. That's all I needed to know. This should be plus 21. Thank you. What? Well, you're ruined for the day, but everyone else is okay.
We have to survive.
All right.
Survive it for us.
So we're going to go through, ladies and gentlemen, and teach you how to run a program on your calculator. So you're going to turn it on, and you're going to go to Program. There are 3 options. EXC means to execute a program. EDIT means to edit a program, and NEW means to write a new program. Unless you know how to write programs, do not go to New or Edit. Do not go to Edit. You start editing and deleting this program, it is garbage. It will do you no good on your quiz or test. So all you're going to do is execute a program. You're going to run a program. So we're going to hit quadratic. So your calculator's sitting here flashing. It's going, all right, tell me what to do. Hit enter again. It's going to ask for A. What's the A value? Negative 16. What's the B value? Positive 21. And what's the C value? 5. Dun, 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 dun. It gives you 2 answers, ladies and gentlemen. Is that what we want to have? How many solutions does a quadratic have? 2. So we should have 2 answers. One of these is no good, though, for this problem. And guys, mine has e to the negative 1 and e to the 0 because I was in scientific notation mode for my freshmen. Which of those answers is no good for this problem? Why negative 2? Well, because we're talking about how much time, correct, ladies and gentlemen? Can I have negative time? No. So my correct answer here is going to be 1.5. Now I need to go back there. Yes, because my answers in scientific. No, I'm sorry. My answers are in scientific notation, guys. So do the rest of you have negative 0.2 like Eric does? Okay. My calculator was in scientific notation mode, and I need to change that. I forgot. Second hour I had been doing that. So what we need to do is go back to our problem. How much time until the ball hits the ground? We know it was 1.5. You need to get a label with it. And we're going to get our label from our velocity. It's traveling in feet per second, so it's going to be 1.5 seconds. Okay? Most things travel in seconds when we talk about velocity, but you do want to check that time. All right? Are we good to go? All right, let's try another one. A baton twirler tosses a baton into the air from a height of 6 feet above the ground. That means 6 is our what? Our height, our h sub 0. That's the height that goes in the equation. With an initial velocity of 45 feet per second. So that's our v sub 0. But this time the twirler is catching it. She doesn't want her baton to hit the ground. That's a mess up. And she's going to catch it at a height of 5 feet above the ground. This is just our h. This is our ending height. How long is the baton in the air? This means we want to solve for t. So I'm going to use my equation. H equals negative 16t squared plus v sub 0 t plus h sub 0, and plug in what I know. Do I know the ending height that we want to reach? Now we want to reach an ending height of 5 feet. I wrote that in green. Negative 16t squared is always there for these motion dropping problems. Do I know my initial velocity? So I'm going to have plus 45. It needs to be t, because that's your b value. And do we know the initial height that she threw the baton from? 6. So we're going to have plus 6 here. Now, ladies and gentlemen, I can only run the quadratic program when it's set up to use the quadratic formula. And what do we have to be equal to in order to use the quadratic formula? 0. So how do I get rid of this 5? So I'm going to subtract 5 from each side, which means now my C value is no longer 6, which is why it's not just a matter of like, oh, I'm going to pluck numbers out of the problem and throw them into the calculator. You got to write that equation out so you can see what your actual A, B, and C values are. It has to equal 0. So we're going to have negative 16 for our A value, because we have 0 equals negative 16t squared. We're going to have a B value of 45, because we have plus 45t. And then positive 6 minus 5 gives me a plus 1 for my C value. At this point, we are literally just going right back to the calculator.
And I guess I'm hit program.
Yep, hit program.
And it's already highlighted on EXCC.
Yep.
And hit what?
So then we go to program. If it's highlighted, either hit enter or hit the number 1.
That's just a blank screen.
Then you hit enter. Did it bring up program quad? You might. I didn't load it on any other calculators.
Oh, okay.
You
That's
might not
fine.
have it. Yep, it's probably not loaded on yours.
That's fine.
So then I can do that. Negative 16. What was our velocity? 45 for this one? And we want a height of 1 foot. Oh, I didn't. Well, I know. I put it in scientific notation form, and poor Mr. Campbell is going to say he can't do the problems because I had him in the wrong form. All right, negative 0.02, 2.8. I can't use the negative, so I have 2.8 seconds. So that's... I know it's seconds because it said feet per second. Yes, Keisha.
How do you like know you put like seconds?
Because I go back to my velocity. So whatever the time unit being used with your velocity is going to be the time unit that you're measuring in. Okay? If they wanted us measuring something in a different unit of time, they would have to put that in our velocity. Now they could ask you a second question. If they said how much time in hours, then we would have to convert our answer to hours or do some conversions. But your answer that you get when you solve this problem matches the units on your velocity. All right? Ladies and gentlemen, what we're going to do today is just go through all the notes. Tomorrow we'll come in and work on the word problems. Okay? So I know somebody got people looking at the clock. We have 15 minutes of class left. Let's please go through these together. Stick with me. And we probably won't have any homework tonight. Versus all right, an object is dropped. This is pretty key here because when I'm dropping, ladies and gentlemen, I'm not putting any force behind it. So if I wanted to drop a book off the top of the building and see how far it lands, if I wanted to drop a student off a cliff, I would not have any initial velocity. So we're using kind of this, basically the same equation. You're just missing that middle term of v sub t. We're dropping them from a height of 17 feet above the ground. How long till the object hits the ground? So we're going to use h equals, we always have that negative 16t squared. But because there's no initial velocity, it's just being dropped, you're just adding the initial height. So I don't really think of it as a new equation that I'm memorizing. I'm just thinking of it as I have 0 initial velocity. All I'm doing is dropping it. Gravity does it from there. Hitting the ground. What does that tell me about my final height?
0.
My final height is 0 because I'm at the ground. So this is equal to 0. We're going to have negative 16t squared. And Monica, what's going to be my h sub 0? What's my initial height? 17, because that's how high I was when I dropped it, or how high I'm shooting something from. So plus 17. So now we are right back to that graphing calculator. So I'm going to go to Program, Execute, do not edit. If you get in the Edit menu, ladies and gentlemen, this is what it's going to look like. Do not hit Clear. You do not want to clear your screen. Clear will erase parts of your program. You want to second quit out of there.
Right there.
Oh, right there, yeah, to do to someone on their test.
Yeah, right through that for test.
I would.
Oh.
I know
Right.
Okay, here's what I would do then, ladies and gentlemen. If you're concerned about calculator pranks, I would make sure the day of the quiz that you know you have a problem with the correct answer, like something from your notes. Run your quadratic program, and not just for a prank. I have students that happens to all the time. They delete things on their own. They loan a calculator out to someone, and things get deleted. That's a good way to, just a good check to do before you run it. But yes, to check out for pranksters. Negative 16 is my A value. What's my B value? 0. Beautiful. No, because it's already, we want it set equal to 0. Is this equal to 0? Yes. And so my B value is 0. I had no initial velocity, but I was still at a height of 17. Once again, I have negative time, which I cannot use, so I have 1.03. All right, so that's going to be one type of quadratic equation that we focus on, are these velocity problems, these dropping, finding heights and times. The other one is number 4. The other place that we find a lot of quadratic equations in is in area, because area is 2 dimensions being multiplied together. So we know the area of a rectangle is 24.5 inches squared. The length is x plus 42, and the width is just x. I want to find what is the actual length, what are those dimensions, and what is the actual width. So I want to know it's 6.5 inches and 3.8 inches. Well, how do we use this information to help me? If I'm giving area, I know that I'm going to use area equals length times width. And so from there, I'm going to plug in what I know. I know the area is 24.5. I know that the length is x plus 4.2. And I know that the width is x. I want to be able to have a quadratic equation that I can find an A, a B, and a C value for in order to run that program. Can I identify A, B, and C with my equation like this right now? No, because I don't even have an x squared term yet. What do I have to do with this right-hand side so that it creates an ax squared plus bx plus c equation?
Make it normal.
Make it normal. How do I do that? Good job, Alan. I need to distribute. So I'm going to have x squared plus 4.2x. Well, it's similar to what we had on previous problems. I can't run my program unless it's equal to 0. How am I going to make this equal to 0? Minus the 24.5. Seems pretty easy from here, right, guys? We want to be careful. I'm going to show you guys something with this one. And this is where people usually end up missing points. They can write the equation. You guys can distribute and subtract 0 because those are things that we've done quite frequently. What you need to make sure is that you run your program. Still nothing new here. I think we just had, was it just 1x squared that we had? No, A was 4. Help me out here, guys. What was our A value? 1. What was our B value? Was that 4.2? And then negative 24.5. All right. So I'm going to get these decimal answers. We're going to round to the nearest 10. I obviously can't use a negative answer for my side length. So what answer am I taking from this program? 3.3. So I know that x equals 3.3. But this is where people run into the problem because they don't start it the way I did. They don't write down that I need length and width. They stop with x equals 3.3 and move on because that's how all of our other problems are done. Find time, find time, find time. I have to find two dimensions. I know that x is 3.3, so I know my width is going to stay just 3.3. I don't have to add or subtract anything to get the width. But what am I going to have to do to find the length? I'm going to have to plug the 3 in for x and add 4.2, and that's where I get 7.5. These still have to have some sort of units to go with them. So what units are going to go with those? How do we determine whether it's going to be feet, centimeters, meters, inches? Inches. Where do you get that from? Beautiful. They give you the units you're supposed to use. So this is 7.5 inches and 3.3 inches. The area problems aren't difficult. They just have that second step that we haven't had anywhere else in the previous problems. All right? So ladies and gentlemen, what I would like you to do now